All right, we're going to construct a binary tree from a preorder and inorder traversal. So really quick, if you need a refresher on preorder and inorder. In a preorder traversal, we do something with the value first. We start at the root node and we do something with the value. Then we go to the entire left subtree. And then we go to the entire right subtree. Then in inorder traversal, we start at, say, the root node, and we would go through the entire left subtree, do something with the value in that root node, then go through the entire right subtree. Now let's take an example here of how this helps us. So we can agree that the first node in the preorder array must be the root, right? Because if we do a preorder traversal on any tree, the first node we're going to print the value of or do something with the value of must be the root node, because VLR, we do something with the value first. Okay, so this must be our root. Now, if we find this value in our inorder array, well, remember, in an inorder traversal, we would go to the entire left subtree first, then process the value of our root node, and then go to the right side. Well, if we find this root node in our inorder array, this must mean that the entire left side is the left subtree, and everything to the right is in the right subtree. So what we're going to do is first we're going to map all of our inorder values to their indexes so that we can quickly find where are these values in our inorder array to quickly know where our left and right subtrees are. And all we have to do is we have to keep track of the size of our current subtree that we're processing. So for example, in the very beginning, the entire array is the root node and everything below it is just one giant, you could say that's one giant subtree. And then when we recurse on the left side, this is another subtree, this is another subtree. And then we're going to recurse again and again, and our subtrees will get smaller. So we just have to keep track of the size of our subtrees. So anyway, let's start building out the code. So we're going to create a map of integers. And we're going to map everything in our inorder array, or the values in our inorder array to their indexes. So map.put inorder I to I. So I'm just mapping the values to their indexes. Okay. And we're going to do this recursively. So we need a helper method. So we're just going to say return build tree. We'll pass in the preorder array. We don't actually need the inorder array because we now have this map that will give us everything that we need. So now we need to pass in, we're going to pass in 0. So this is the index of the root node that we're currently on in the preorder array. So in the beginning, it's just 0 because that's the root node. And we need to tell this recursive method the bounds of the tree that it's currently processing, or the bounds of the current subtree that it's processing. In the beginning, it's the entire tree. So this would just be 0 to inorder.length -1. Okay. Now let's actually build out this. Let's make this private method. Okay, so let's build out the recursive method. I'm going to pass in preorder. Or what am I doing? Has to have types. Preorder. This needs the map. So let's copy paste this. What else am I missing? The pre-start. Okay, so, or this would be, let's just call this pre-order index. It's such a long variable name, but whatever. Int preorder index. And so this would be the root node that we're currently processing. And then we want to say int inorder start. So this is the starting bound of my current tree that I'm processing. So inorder start and inorder end. And here's our base cases. So if first we need to check that this is still in bounds. So we're just gonna say preorder index. If it's greater or equal to, which it'll never be greater, we could just do equals if we wanted to, but whatever. Preorder.length. Yeah, so if it's greater or equal to the preorder.length, then we're going to return null. But we also need to check if we still have a tree to actually process, because if this basically, so if in order start is greater than in order end, then we don't have anything. We don't even have a tree to work with, so we would just return null here. So for example, let's just go through, like, if we had a single, let's just say we had a single node tree. So in this, all this tree has is the number 5. Well, then in order start would be 0. The length of this would be 1. So that means 1 minus 1 is 0. So is 0 greater than 0? No. So we're going to skip past this, and we would create a node out of this tree, or sorry, out of that value. But anyway, let's, actually, wait, I need to pass in the value. So that would be preorder index. Okay, so all I did was I passed in the value of the current root of the subtree that we're processing. And now we need to do root.left equals something, root.right equals something, and we return the root. Okay. So for root.left, we're just going to recurse on the left subtree, and then for root.right, we're going to recurse on the right subtree. So we're going to, let's do that. So we pass in the preorder array, pass in the map, pass in, so this would be preorder index plus 1. Why? Because if you think about what in a preorder traversal, so the first node that we hit is the root, right? In a preorder traversal, well, the next node that we process is going to be the first node in the left subtree. So that would just be preorder index plus 1. So yeah, so this would be the root of our left subtree here. So now we need to pass in the bounds of this left subtree. So that's going to be in order start. And okay, so for the right, okay, so first we need to get, let me copy paste this to explain this. Put this right here. Actually, no, let's put it up here. Okay, so let's say we're on this 3. This 3 is located here in this inorder array. So once we grab this index, we know that everything to the left is the bounds of our left subtree, and everything to the right is the bounds of our right subtree. So first we need to grab this index. We need to figure that out, which is just int inorder index equals map.get. So we need to pass in this guy right here, the value that we get from the preorder array. So this would be the 3. And now we're passing this into our map, which would give us back, it would give us the index 1, because we mapped our values to indexes earlier. And now everything to the left of that would be the left subtree, and everything to the right is the right subtree. So let's actually use this. So now if in order start is my left bound for my left subtree, the right bound is going to be in order index minus 1. Because if this would be my in order index. So in order index minus 1 puts us here, which would be 0. So in this case, in order index equals 1, 1 minus 1 is 0, and in order start will equal 0. And on the next recursive call, it'll we'll just get the node for this value 9 here. Okay, so anyway, now let's do the right subtree. So build tree, preorder, pass in the map, pass in. This would be, okay, so in a in-order traversal, or sorry, so what we need here is we need the index of the first node in our right subtree. So first, let's say, okay, let's start with this. So we have preorder index, right? This preorder index would be, let's actually move this down here to explain this. Let's fix the spacing. Okay, so this preorder index would be this node here, right? Or sorry, this would be this node here, this value here, because 0. What we want to know is where is this we want to know where the first node in our right subtree is. So what we need to do is we need to take the size of our left subtree, add 1 for the root node that we just processed. So this would be +1 for this guy right here. So we 1 plus the size of whatever our left subtree is. And the preorder traversal, if you remember, the preorder traversal goes, it does something with the value in the node first, then it goes through the entire left subtree, and then it processes the right subtree. So we need to take, so we would add 1 for this guy, then the entire size of the left subtree, and if we do, so 1 plus the size of the left subtree would give us the index of the first node in our right subtree. So we're going to do preorder index plus 1. So this is the current node that we're starting. So this would be our current root node. This would be, so preorder index is the root node of the current subtree that we're processing. We're adding 1 to skip over that node. And we're going to add the size of the left subtree. So let's get this value here. So int left subtree size. So this would be equal to our inorder start. Or actually, it would be inorder index minus inorder start. So this is the index of our root node minus the left bounds of our current tree that we're processing. And this would be the entire size of the left subtree. So yeah, so we add 1 for the root node plus the left subtree size, and that'll give us the first index of the right subtree. Okay, and then what do we want to pass in here? Our new bound. So this is the right subtree. So this would just be inorder index. So this would be the bounds of the right subtree. So this would be inorder index plus 1 all the way to inorder end. Okay, I think we're good. Let's run this, make sure it all works. Legal start of expression. Did I not comment something out? Let's clean this up a little bit. I'm just cleaning up the code a little bit because it looks terrible. Okay, where's that? Oh, okay, there it is. All right, let's run this. What did I do wrong? Oh, I didn't put a semicolon. I should normally, I would have used shorter variable names to like make this fit in better, but I wanted to be really clear. Okay. Cool. So that works, and that's how you do this. And this is what would be the space. Well, the space is O of n because of the recursion and also the map up here. And the time complexity would be, I believe it's just O of n. Yeah, the time complexity is O of n because we are just going through every single node. But anyway, yeah, so if you have any questions, you can ask in the comments. And if you like the video, you can give it a thumbs up. All right, bye.